Hello everyone, welcome back to Diksha Karnataka YouTube channel, and today I am going to bring you the passing package for PU final board exam, right? So all of you are waiting for this passing package. If you watch this video, definitely you can score 40-45 marks, but you have to follow all the questions without skipping it. Okay, 40 to 45 marks including your practicals. You should be scoring more than 60 marks in your final PU board exam. So if you have not yet started your physics study, then definitely this is the video that you have to watch. This is for all the weaker section of the class where students have not studied at all throughout the year and then they want to pass the exam. Then this is the video for you. Okay, so let us first discuss what is the paper pattern. So paper pattern is you have to answer 15 MCQ questions and 5 fill in the blanks question. They are compulsory. You have to answer 5 2-marker question out of 8, and you have to answer 5 3-marker question out of 8. These are also important section, and we also have long answer type 3 long answer type questions, 5-marker and 2 numerical questions. Now in this lecture I am not going to discuss any numerical questions. Numerical questions is not part of the passing package, obvious reason, because you have not studied throughout the year. You want to pass the exam somehow, then obviously you will not have time to do the numericals. But if you want to practice the numericals, there is a separate video completely dedicated for numericals where I have solved 21 very important numericals. You can go and check that video. That is very important for all of you if you want to score marks in the numericals as well. Okay, now we are going to discuss about 30 MCQs. Not all the MCQs are going to come in your exam, but similar pattern, similar type of MCQs will definitely come in your exam. So that is the goal, to give you an idea what type of MCQs you can expect in your final exam. Now you should target at least out of 15, at least 12 MCQs you have to correct it. Okay, there is no other option. These MCQs are very scoring. Don't write answers randomly. Think before you write your answer. I am going to discuss that through these 30 very selective MCQs. So the dipole moment is a vector quantity which is pointing from. So you have to know that dipole moment is a vector quantity which points from negative charge to positive charge. So minus q to plus q along the axis of the electric dipole. So this is the correct answer for this. Okay, obviously other options are not super suitable for this question, so only option A is the correct answer. Now next question. The electric potential due to a negative point charge at a distance r is. So electric potential due to a negative charge is 1 by r square. Okay, it is positive and it varies as 1 by r square. You have to remember that electric field varies for a dipole 1 by r cube. For electric potential is varies as 1 by r square. The following are the statements related to the self-inductance. The self-inductance of a coil depends on the geometry and on the permeability of the medium inside it. The self-inductance is a measure of electrical inertia and opposes the change in the current in the coil. So both of them are correct statement. So both statements are correct. So option C is the correct answer for this MCQ. So you have to be careful, check whether both statements are correct, and if this is a reason assertion based question, you have to check whether it is basically assertion or not. Assertion is basically reason or not. In this case they are independent statements, both are correct statement, so you have to make both of them are correct. A ray of light is incident on a glass air interface at an angle greater than the critical angle for the pair of the media. Then the ray undergoes. So the incident angle is greater than that of the critical angle, so it undergoes total internal reflection. If the angle is equals to critical angle, it grazes the medium. If it is less than critical angle, then it goes to the other media. So basically it's a kind of refraction. Now statement 1, the resistivity of metals increases with increase in temperature. Increasing the temperature in metals causes more frequent collisions of electrons. So basically this is the assertion and reason based type question where both statements are correct, and statement 2 is basically correct explanation of statement 1. So both 1 and 2 are true, and 2 is the correct explanation of 1. Yes, so this is the correct answer. Now next, Lorentz force is the force on a charged particle moving in a region containing both electric and magnetic fields. Okay, so both electric and magnetic field is the answer. Lorentz force is basically force when it acts on a charged particle when it is moving in both electric and magnetic field. Okay, now question number 7, a match the following type question. Match the following type question, there will be at least one match the following question in your final board exam. So self-induced EMF, self-induced EMF is called back EMF. Okay, so you have to be careful, and other way is to, even if you don't know the answer, you have to see which one you are definitely sure about. EMF induced in a rod moving in a magnetic field, so that is called motional EMF. So induced in a rod moving in a magnetic field motion, so that is motional EMF. AC generator is electromagnetic induction by changing the orientation of the loop. That is the we induce EMF, right? In an AC generator it produces current. And then transformer works under the principle of mutual induction. Okay, so this is the match A with S. So if you see, there are only two matches with A with S, so one option A or option B, option D. So in case you are not able to completely match the following, suppose you have matched only 1 or 2, so you have to check which one of you have been able to match them correctly. Now if there are both of them are coming in the two options, then you have to have some patience. Okay, and then you have to realize it later on. You can skip the question, okay, and answer it at the last moment. Otherwise, if you are sure, then you have to answer it as soon as possible. So A is matching with S, B is matching with P, that is also correct. C is matching with R, but in this case C is matching with Q, so option A is the correct answer. Okay, so because the last one is incorrect. Okay, so for example, if you have figured out that D is matching with R, then you don't need to do anything else. You just check, okay, D is matching with R, that means this will be the correct answer no matter what. So these are the things that you have to understand. Okay, in the match the following question, mostly last match or second last match gives you the correct answer. So you have to be careful. If you have figured out that transformer is mutual inductance, then you are sure that option A is the correct match, because only one option with D matching with R, right? Now next question, the average power dissipated in an AC circuit is maximum if the AC source is connected to only a pure resistor, only to a pure inductor, only to a pure capacitor, the series combination of capacitor and inductor. So power dissipated is maximum when it is connected to pure resistor. When the circuit is purely resistive, power dissipated is maximum. The displacement current is due to flow of electrons, flow of protons, changing electric field, changing magnetic field. So displacement current is due to changing electric field. Another statement based question, the net magnetic flux through any closed surface is 0. The number of magnetic field lines leaving the surface is balanced by the number of lines entering it. So basically both statements are again correct. Okay, both statements are correct, and obviously because number of field lines entering through the surface and the exiting through the closed another surface is basically balanced, that means total flask magnetic flask is 0. So that is correct explanation. So both statements are correct, and 2 is correct explanation of the 1. Now number 11, electromagnetic waves with lowest frequency among the following are. So lowest frequency means highest wavelength. Frequency and wavelengths are inversely proportional, so lowest frequency means highest wavelength. Now if you see gamma ray, UV ray, they are all higher frequency, whereas microwaves is in between, and radio waves is the lowest frequency because it has highest wavelength. So from the given option, radio waves is the correct answer. The current density is a scalar and its unit is ampere meter square. Vector and SI unit is ampere per meter cube. Vector and its SI unit is ampere per meter square. Scalar and its SI unit is ampere per meter. So current density is a vector quantity and its unit is ampere per meter square. Okay, don't get confused with any other units. The straight conductor of length L is moving with the velocity v in the direction of uniform magnetic field of strength B. The magnitude of EMF induced between the ends of the conductor is BLV by 2, 0, 2 BBL. Okay, so length L is moving in the velocity v in the direction of uniform magnetic field, okay. So because the magnetic field and the motion both are in the same direction, okay, and we know that the induced EMF is basically I into V cross B, okay, not I, sorry, it is L, length is L into V cross B, okay, because V and B are in the same direction, V cross B will be 0, so that means it will be BV sin theta. Now because they are in the same direction, theta is 0, so that means induced EMF is 0. If they are perpendicular, if V and B are in perpendicular direction, then it will be BVL or BLV. But since they are in the same direction, the induced EMF will be 0. An object of finite height is placed in front of a concave mirror within its focus. So concave mirror is concave mirror. This is a class 10th question, and object is placed within its focal length. Within its focal length means it always produces a virtual and erect image. It produces a virtual and erect image and magnified as well, because concave mirror, right? So a virtual and enlarged image is the answer. The ferromagnetic material among the following is, so which one of them are ferromagnetic material? Copper, nickel, lead, calcium. So nickel is a ferromagnetic material, okay, copper is diamagnetic, lead is paramagnetic, calcium is I think also paramagnetic, sorry. In a purely capacitive circuit, if the frequency of AC is doubled, the capacitive reactance will get doubled, becomes 4 times, get halved, remains constant. Okay, so capacitive reactance is basically given by 1 by 2 pi Fc. Okay, so if you double the frequency, that means the capacitive reactance will be half of the initial value, because it is inversely proportional. Inversely proportional means if you increase one quantity, other quantity will be reduced, so it becomes halved. Okay, get halved. But in case of inductive reactance, on the other hand, inductive reactance is 2 pi FL. So if they ask you the same question with inductive reactance, in that case inductive reactance will be doubled. Okay, so new inductive reactance will be double that of the initial value. The power factor of a series LCR circuit is maximum. So power factor is maximum when the circuit is at resonance, and for the condition of resonance it is XL equals to XC. Okay, that is the condition for resonance. Next, which of the following phenomenon confirms the transverse nature of light waves? So polarization of light, diffraction of light, dispersion of light, refraction of light. So out of these, only polarization of light proves that light is a transverse nature. Light is a transverse wave in nature. So that is the main thing that you have to remember. Polarization is the only way to detect whether light is transverse or not. While both light and sound show wave character, diffraction is much harder to observe in light. Why? Because obviously wavelength of light is very small, so you need a very small gap to observe diffraction of light. In case of sound, the wavelength is very high. Even a large wall can act as a slit for sound wave, but for light it has to be very sharp, very thin, of the order of the wavelength. So wavelength of the light is far smaller is the answer. The gathering and focusing mechanism of light by the eye lens is described by wave nature of light. So the eye, when it gathers and focus the light into the retina, that is part of wave nature of light. There are some other things that actually can be explained by photon nature of light, but gathering and focusing is based on wave nature of light. The slope of stopping potential V naught versus frequency nu in the Einstein's photoelectric equation. So in the Einstein photoelectric equation, E V naught equals to h nu minus phi. Okay, phi is the work function. So V naught equals to h by E into nu minus phi by E. Right, now if you compare this equation with y is equal to mx plus c, where m gives the slope of the straight line. So this is a straight line with this as the slope of the line. Okay, v naught versus frequency. So v naught versus frequency graph means y versus x graph. So it will be h by e. H by e is the correct slope. The alpha particles are H atom, H plus atom, helium plus 2 atom. So alpha particles are helium plus 2 atom. According to Louis de Broglie, waves associated with orbital electrons are progressive wave, stationary wave, longitudinal wave, continuous wave. So according to Louis de Broglie, waves associated with orbital electrons are stationary waves. Okay. Mn and Mp represent mass of neutron and proton respectively. If the element having atomic mass capital M has n neutron and z proton, then the correct relationship will be. So atomic mass is M, number of neutron is n, mass of neutron is Mn, and mass number of proton is Z, mass of proton is MP. So definitely this is the total mass of the nucleons. Total mass of the nucleons will always be greater than that of the atomic mass. So M must be less than that of this thing. So M must be less than that. So option A is correct answer for this question. Mass of the nucleons is always less than that of the mass of the atom. Radioactive substances emits alpha rays, beta rays, gamma rays, all of the above. Yes, they emit all types of rays, so that is why all of the above. A semiconductor doped with donor impurity is a p-type, n-type, npn type, pnp type. Donor impurity means it is giving electron. Okay, donor impurity means it is giving electron. That means electron is extra. Electron extra means it's an n-type semiconductor. If it is a accepted impurity which is accepting electron, then it will be p-type semiconductor. Okay. Which of the correct diagram is of a half wave rectifier? So half wave rectifier contains only one diode which is connected before the capacitor. So this is the correct diagram. Option B is the correct diagram for this question. We are expected to get at least one diagram based questions as well. N-type semiconductors is electrically positive, negative, neutral. As temperature increases, it becomes negative. So N-type semiconductor are always electrically neutral. N-type semiconductor, P-type semiconductor, extrinsic semiconductor, intrinsic semiconductor, no matter what is the semiconductor, they are always electrically neutral. Only thing that we are creating is making more free electrons available. Okay, that is the only thing that is the N-type semiconductor is doing. But total number of protons, total number of neutrons are always same. Total number of electrons and total number of protons are always same. So the total charge is always 0. The equation AB equals to C. A is a current density, C is the electric field, then B is. This is a hot question. So AB equals to C. Okay, A is current density. Current density means J. Okay, C is electric field. So C is electric field. Okay, now we know that there is a relationship, alternate Ohm's law, J is equal to sigma E, right? So from there, if we write E equals to J by sigma. Now what is 1 by sigma? 1 by sigma is nothing but resistivity. rho. So E equals to J rho. So here if you see that only B is alone, that means E must be equals to that rho that we have found here. So it is a resistivity. It is the resistivity. Okay. The rectangular coil carrying current is placed in a non-uniform magnetic field. On the coil, the total force is non-zero, force is 0, torque is 0, none of the above. So a rectangular current carrying coil, okay, is placed in a non-uniform magnetic field. On the coil, the total force is not 0. Okay, torque is always not 0 because it is a rectangular coil, and if it is a non-uniform magnetic field, then the force will also be not 0. So force is not 0. If it is a uniform field, force will be 0, torque will not be 0. Okay, but in case of non-uniform magnetic field, both torque and force will be non-zero. So only the option is given, force is 0, torque is 0, which are not. Force is not 0 is the answer. Now let's move on to the fill in the blanks. Now this is an example of fill in the blanks. Obviously this exact 5 fill in the blanks will not going to come in your exam, but if you practice, if you know the strategy to answer, then you can answer even if you don't know all the answers. That is the main thing. So on the basis of properties, one of the basic properties of electric charges. So there are 3 basic properties of electric charges. Charges are additive, charges are scalar, and charges are quantized. Okay. So in this case, if you see, only quantization is given as an option. So definitely quantization is the answer for this option. Okay. The distance between plates of a capacitor is increased, the capacitance. So if you increase the distance between the capacitor plates, its capacity decreases. Okay, we know that capacitance is given by normally in air capacitor epsilon naught A by D. Okay, so if you increase the distance, okay, the capacity will decrease because it is inversely proportional. So increasing D will decrease capacitance. Okay, so option will be decrease. Okay, now here there is a trap. Increase, decrease both are given, but you have to careful, only decrease is the correct answer, increase is not the correct answer. Okay. The device which works on the principle of electromagnetic induction is there. Now you have to check device. They are talking about device. Is there any device mentioned in here? Phasor is not a device. Diamagnetic is also not a device. AC generator. AC generator is type of a device. So answer will be AC generator. Even if you don't know the answer, you have to think logically, use your head that okay, the question might be tricky for me, but I have to read the options and then I will decide. A rotating vector used to represent alternating quantities is called phasor. Okay, this has to be a knowledge based question. If you don't know, you may not be able to answer it, but from the given option, phasor and diamagnetic, obviously diamagnetic is not the vector, so it will be definitely phasor. So by that logic you can answer phasor. Now the magnetic susceptibility is negative for materials. Now what is a material? Only material that is diamagnetic material. Okay, so definitely diamagnetic will be the answer. In case there will be an extra option which will be confusing, but that will be for only one question. Okay, so don't fall for the trap. Try to find the answer logically and write it. You will always score at least 4 marks, even if in the worst case scenario. Now write Coulomb's law in vector form, explain the terms. They can ask you write Coulomb's law or state Coulomb's law. Both are possible. 2 marks, 3 marks question can come from this. Now we are going to discuss 2 marks, 3 marks, by the way. So if you are wondering, so MCQ and fill in the blanks part is over. So statement Coulomb's law states that the electrostatic force between 2 point charges is directly proportional to product of the magnitude of the 2 charges and inversely proportional to the square of the distance between them. Coulomb's law in vector form is F vector equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. Now here you have to draw a small diagram like this. This is Q1, this is Q2, and the vector, this is say R cap. Okay. Now this is the explanation. Also you have to determine say what is what. Now next question, on what factors does the capacitance of a parallel plate capacitor depends? So what is the expression for parallel plate capacitor? If you remember, I told you it is in this case I will add a new term, K epsilon naught A by D. So K is the dielectric constant, A is area, and D is distance. So directly proportional to the area. So C is directly proportional to area. So area increases, capacitance increases. Inversely proportional to the distance between the plates. So inversely proportional to the distance. So whatever is denominator is inversely proportional, and directly proportional to the dielectric constant kept between the medium. So this is also directly proportional to the dielectric constant. Now next question, when does current carrying conductor placed in an uniform magnetic field experience maximum force, minimum force? So when the current flowing perpendicular to the direction of magnetic field, it is, so when the current is flowing perpendicular to the magnetic field, the force is maximum. Okay, and when the current is flowing in the direction of the magnetic field, the force is minimum. Okay, that is 0. Now next, state Faraday's law and Lenz's law of electromagnetic induction. So Faraday's law, the time rate of change of magnetic flux through a circuit induces EMF in it. Lenz's law, the polarity of induced EMF is such that it tends to produce a current which opposes the change in the magnetic flux that produces it. So epsilon equals to minus d phi b by dt. Okay, epsilon is the induced EMF, d phi b is the d phi b by dt is the rate of change of magnetic flux. Okay, now you might say, sir, I did not understand how you wrote this phi, so let me give you an idea. So you have to draw this. Okay, then it's like this, right? Ragi mudde, cut from the middle and add a b in the denominator, in subscript. Okay, mention two limitations of Ohm's law. Ohm's law is applicable only if the physical conditions remain same. Ohm's law is not applicable at very low and at very high temperature. Ohm's law is not applicable to non-ohmic devices like semiconductor devices, discharge tube, etc. Okay, so these are the three limitations of Ohm's law. Very common, easy questions. You have to practice all these questions. Write any three properties of electric charges. Additivity of charges, charges are additive in nature. Quantization of charges, all the charges are integral multiple of smallest charge E. Conservation of charges, total charge in an isolated system is always conserved. Okay, so these are the three charges. Try to write the one extra line so that you don't miss out on any marks. Now derive the relationship between electric field and electric potential due to a point charge. So here we have to draw a electric equipotential surface. So this is the equipotential surface of potential V. This is the equipotential surface of V minus dV. The distance between them is dl. Okay, so distance is dl and the potential is dV. Now how to solve it? First of all, we will do the mechanical way. How to do the mechanical way? So when you keep a charge, say Q over here, if you keep a charge over here, okay, what is the force acting on this charge? The electric field at this area is E. So the force acting on the charge is basically Q into E. This is the first thing. Now what is the work done? So work done is to move the charge from A to B by a distance dl. The small work done is basically given by QE F into dx. F into dx, right? F into x, fx cos theta, whatever you remember from first PU. Okay, so here F into dl, not x, not L. Only dl. Okay, dl is the displacement, force into displacement is the work done. So this is the mechanical work done. So now put the value of F, that is Q into A into dl. This is the mechanical work done. Okay, now what is the work done in terms of potential, definition of potential? So work done in terms of potential is basically given by charge times change in the potential. Change in the potential means what is the final potential? Final potential is V minus dV. What is initial potential? Initial potential is V, so minus V. Okay, so final potential minus initial potential. Now remember that the final potential is lower here, okay, because electric field always points from higher potential to lower potential. That is why there is a negative. So there will be a Q minus Q dV. This minus sign is very, very important. If you miss that, then marks will be deducted. So now comparing, so this is equation 1, this is equation 2. Comparing 1 and 2, we get QE dl equals to minus Q dV. Obviously Q cannot be 0, so Q cancels. So E is equals to minus dV by dl. This is the relation. If you do it, you get 3 marks. Slight 1-2 lines in between, like comparing 1 and 2 from the definition of potential, from the definition of work. If you write this small words in between, then obviously you will get full marks for this question. Now state and explain Biot-Savart's law with a suitable diagram. So magnitude of the magnetic field at a point P due to the current element dl. So first of all, you have to draw the diagram. You know the diagram, right? This is a current carrying wire carrying current I. So we are trying to find magnetic field at some point P at a distance r. So the angle made by this is theta. Okay, so this is the element dl. Okay, what else? Nothing. So directly proportional to the current I. So it is directly proportional to current I, directly proportional to the length of the current element dl. So it is proportional to the how long you have taken this element, directly proportional to the sine of the angle between the current element and the line joining the given point and the midpoint of the current element. So this is directly proportional to this angle theta. Okay, inversely proportional to the square of the distance between them. So it is inversely proportional to square of the so you can write it here that directly proportional to current I, it is directly proportional to dl, it is directly proportional to sine theta, and it is inversely proportional to 1 upon r square. Inversely proportional means 1 upon r square actually. Okay, so this is, you can write it like that, and this diagram is compulsory. So this is also very common 2 mark, sometimes 3 mark question. Okay, in the 3 mark question they might ask you write the formula as well. Okay, so in that case you have to write dB equals to 1 mu naught by 4 pi I dl sine theta by r square. So if they give you 3 mark, you have to write this equation extra. Okay. Derive an expression for the motional EMF induced in the straight conductor moving perpendicular to uniform magnetic field. Now this is slightly difficult question if you have not studied throughout the year, but this is very, very common, most expected question. That is why you have to practice even if you have not studied physics throughout the year. Okay, that is why I have given this question. Now first thing that you have to do, you have to calculate the flask. Okay, you have to remember one thing, that flask EMF induced is basically d phi by dt with a negative sign, but magnitude wise this is the induced EMF. So if you know phi, if you can find phi, then you can differentiate it and you can calculate the induced EMF. So how to find the phi? What is phi? Phi is basically a magnetic field into area. Okay, so what is the area of this rectangular loop at this point? It is changing, the area is changing, obviously area is changing, so you have to draw this diagram obviously, and the area is changing. Area is changing means you have to calculate d phi by dt. That is the main thing. So what is the area of this? Area is, this is a rectangular surface, so area is length into breadth. So length is given here, so if you see, length is given here L and breadth is given here x, so L into x is the area. Okay, so B is a constant quantity, but area is not, L into x. Now if you see that as it is moving in this side, okay, L remains same, but the x is changing, x is decreasing. Okay, so how this is changing, let's see. So d phi by dt equals to B is constant as I said, L is constant as I said. Now only x is changing, so dx by dt. Now if you have studied some concept in your first PU, dx by dt is the rate of change of displacement. Rate of change of displacement is nothing but it is called v, velocity v. Okay, so the induced EMF is basically BLV. Okay, this is the expression, as simple as that. If you can do that, you get full 3 marks. Okay, this is generally a 3-mark question. Diagram is compulsory for this question. If you don't do the diagram, if the teacher is very strong, he might give you 0 marks. Okay. Now write the 3 differences between diamagnetic, paramagnetic, ferromagnetic. Now it is a very common question. Any one of the pair might come, and 2 difference or 3 difference, both type of questions can come from this part. So let's see. Property is magnetic behavior. They are weakly repelled by magnetic field. They are weakly attracted by magnetic field. They are strongly attracted by magnetic field. So one table will prepare you for 2 different types of questions. Magnetic susceptibility, have a small negative magnetic susceptibility chi less than 0. Have a small positive magnetic susceptibility chi greater than 0. Have a large magnetic susceptibility chi greater than 0. Okay, effect in magnetic field induces a magnetic moment in the opposite direction of the applied field, induces a magnetic moment in the same direction of the applied field, induces a strong magnetic moment in the same direction as the applied field. Okay, so this is a very important question to remember, and one table to remember for all of your paramagnetic, diamagnetic, ferromagnetic related questions. Okay, also if you want to get this PDF, then 2 things that you have to do. First of all, you have to subscribe to our YouTube channel. Secondly, you have to join our WhatsApp channel. We will provide the link for all the files that we have done in our entire PU2 series. So join the WhatsApp group now. One set of PDFs are already shared, and if you keep on continue asking in the video, sir PDF, sir PDF, sir PDF, you have to join the WhatsApp channel. There we will share the PDFs, nowhere else. Okay, obtain the expression for the effective capacitance of 2 capacitors connected in parallel. So we have 2 capacitors connected in parallel. So we have done some more 2-marker, 3-marker question where we have done almost 60 plus 2-marker, 3-marker question. If you get time, don't forget to watch that out as well. Okay, there we have done series 1 as well, but parallel one, if you are lucky, if you are getting a little easier question, maybe you will get a parallel connection. Now in case of parallel connection, okay, the charges in both the capacitors are not same, but the voltage is. Any parallel combination of resistor, capacitor, or whatever you are using, parallel combination means the voltage is same, but the current or charge is different. So in this case, as you can see, the charges are different but potential is same. The total charge, however, from the conservation of charges, we know that charges cannot be destroyed or created, so Q1 is equal plus Q2. So Q is basically Q1 plus Q2. Now if you draw a equivalent circuit diagram of this, equivalent circuit diagram will have only one capacitor, only the same voltage supplier. Okay, but the charge in this case will be the same, that is the total charge Q. Okay, this is C equivalent. So we will try to find this C equivalent. Now what is Q1? So let's see that. So we know that this is say C1, this is C2. We know that Q1 equals to C1V. Q is equal to CV. That is the basic equation that you need to know to solve this thing, right? So for Q1, for capacitance 1 equals to Q1 equals to C1V. Okay, similarly Q2 will be C2V. For capacitance it is always Q equals to CV. Okay, now if you add these two quantities, okay, then you get C1 plus C2, common is V, right? Now This is the thing. Now if you apply the same thing to the equivalent circuit, you get, now what is Q1 plus Q2? By the way, first let us simplify this. So Q1 plus Q2 is Q equals to C1 plus C2 into V. Now if you apply the same thing in the equivalent circuit, you get Q equals to C equivalent into V. Okay, now if you compare equation 1 and equation 2, you get C1 plus C2 equals to C equivalent. So this is the expression for two capacitors connected in parallel. Okay, in case of parallel, it's just addition of these two. Okay, series one, if you are interested, you can check the longer version of 2 marker 3 marker videos, where this is a scoring, that was a scoring video where you were targeting 70 plus marks. So you can check that video. Mention 2-3 uses of applications of Polaroids. So it might come 2 applications of Polaroids, 3 applications of Polaroids, 2 uses of Polaroids, 3 uses of Polaroids. So all of them are basically same question. So Polaroids are used to control the intensity in sunglasses, window panes, etc. So did you know that what the sunglass that you are wearing, if it is a costly one, okay, someone gifted you, then that is basically probably having a Polaroid inside it, in the screen itself. Okay, all the cricketers, all the sports persons, they wear very high quality sunglasses. Okay, they just don't use any coating on it. They are using Polaroids, so that the light sensitivity, it can sense light and it can block some of the lights. Okay, Polaroids are also used in photographic cameras and 3D movie cameras. If you watched any 3D movies wearing glasses, they are basically a Polaroid glasses, unless they are red and green, red and blue glass. Okay, that is very common, available in village fairs. So those 3D are not Polaroids. But if you have visited a movie theater, watch movies using plastic glasses, those are Polaroid glasses. Okay. Now they are used in 3D movie glasses. Okay, now 3D movie cameras and 3D movie glasses. So when recording, there is a thing called 3D movie cameras, IMAX 3D. Okay, IMAX 3Ds are basically Polaroid cameras. Okay, they have Polaroids, they have angles such that when it is recorded in 3D mode, okay, once you see that in 3D mode, it will be a very good experience for you. Okay, most of the Marvel movies, they use this technology, if you have seen. Now mention Einstein's photoelectric equation and explain the symbol. So let's see. So Einstein's photoelectric equation is H nu is equal to 5 plus half mv square, where H is Planck's constant, 6.626 into 10 to the minus 34 joule second. There is a mistake here, it will be joule second, Planck's constant. Okay, next is frequency of the incident light. Nu is frequency of incident light, then phi is the work function of the metal, m is the mass of the electron, 9.11 into 10 to the power minus 31 kg, velocity of the ejected electron is v. Okay, so this is the very common question you have to remember and answer. Write 3 features, properties of nuclear force. So nuclear force is much stronger than the Coulomb force acting between charges, or the gravitational forces between the masses. The nuclear force between two nucleons fall rapidly to 0 as their distance is more than few femtometers. The nuclear force between neutron, neutron, proton, proton and proton, neutron are approximately the same. The nuclear force does not depend on the electric charge. Okay, now question number 15, write 3 limitations of Bohr's atomic model. Bohr's model is applicable to hydrogenic atoms only. It cannot be extended even to mere 2 electron systems such as helium. While Bohr's model correctly predicts the frequencies of the light emitted by hydrogen atoms, the model is unable to explain the relative intensities of the frequencies in the spectrum. So in the hydrogen spectrum, if you see, according to Bohr model, all the lines that is coming in the spectrum should have equal intensities. But in some cases, real life, we see that some of them are very bright, whereas some of them are very faint. Why it is happening? It is Bohr cannot explain that. Okay, The model does not explain the fine structure and splitting of the spectral lines observed under magnetic field, Zeeman effect and an electric field Stark effect. So what is the meaning of that fine structure? That means when we apply some electric or magnetic field, this single line, which was a single line in the spectrum, now split into 3 lines or 4 lines. Okay, based on the properties. So how can a single line now be split into more than one line? Okay, that thing was not been able, Bohr's model cannot be explain that theory. Okay, so that is why this is not super proof theory. Now write the 3 properties of electric field lines. Another very common question. Electric field lines may start from positive charge and end at negative charge. 2 electric field lines are never intersected each other. Electrostatic field lines do not form any closed loop. Okay, so these are the 3 common properties. Write 3 properties of equipotential surfaces. No work is done moving a test charge over an equipotential surface. Electric field is always normal to the equipotential surface at every point. No 2 equipotential surfaces can intersect each other. Similar, so this property is similar for electric field, equipotential surface as well as magnetic field. Mention any 3 properties of magnetic field lines. So let's see. The magnetic field lines of a magnet form continuous closed loops. The tangent to the field line at a given point represents the direction of the net magnetic field at that point, and the magnetic field lines do not intersect. So as I said, so these are the common property. For if they did, the direction of the magnetic field would be not be unique in the point of intersection. So these are the main 2 marker 3 marker question. Okay, now we will see some 5 marker question. State Gauss's law in electrostatics. Derive an expression for the electric field point due to an infinitely long uniformly charged straight wire using Gauss law. So statement of Gauss's law is basically electric flux through a closed surface is basically charge enclosed by it divided by epsilon naught. This is the statement of Gauss's law. Statement you have to write it. Okay, statement is not the equation only. You have to write it. The flux through a closed surface is 1 by epsilon naught times the charge enclosed by the surface. As simple as that. Then you have to use this simple formula. Now let's come to the derivation. So you have a straight wire, charged wire. This is very important for your year. Okay, it is uniformly charged wire, though even though my charges are not uniform. Okay, they are uniformly charged, and you are trying to find electric field at some distance, say r from the wire. How to do that? First of all, you have to construct a Gaussian cylindrical Gaussian surface of radius r. Okay, and length say L. Length say L means L is not given, we are assuming the length. Okay, so this is the assumed Gaussian surface. The charge is the rod is uniformly charged, so the charge per unit length is given by lambda. Okay, so first you have to write, let us construct a Gaussian surface of radius r and length L bracket say. Okay, now the charge enclosed by the surface is QEN equals to. So what is the charge enclosed by this Gaussian surface? Charge enclosed is the charge per unit length is lambda. Okay, and we have assumed the length of this Gaussian surface to be L. So the length is L. That means total charge enclosed should be the charge density, that is lambda, times the length, that is L. This is the total charge enclosed, right? So this is the charge enclosed. Now from Gauss law we know that the phi is basically equals to Qn by epsilon naught, or what is phi? Phi can be written as E dot ds. Okay, you can write vector, you can write scalar, does not matter at this point, but writing vector is more appropriate. E dot ds equals to lambda L by epsilon naught. Okay, now you have to write that E, due to cylindrical symmetry, due to cylindrical symmetry, okay, E will be constant, so E will come out of the integration, you will get close integration ds, that is equals to lambda L by epsilon naught. Now what is close integration ds? Close integration ds is the curved surface. Now the area of the curved surface is basically 2 pi r into L, that is equals to lambda L by epsilon naught. Now L cancels, so you get E equals to 1 by 2 pi epsilon naught lambda by r. So this is the expression for electric field on the axis. So E equals to 1 by 2 pi epsilon naught lambda by r. So if you see that in this case, lambda is E, electric field is proportional to 1 by r. Normally electric field is proportional to 1 by r square, but there are some specific cases where electric field can be proportional to 1 by r cube, for example dipole, and in this is a special case where electric field is inversely proportional to the radius. Okay, now let's move on to the next part. Define electrostatic potential due to a point charge and arrive at the expression for the electric potential at the point due to a point source charge. So the definition of electric potential is basically work done to move a unit positive test charge from infinity to a point in the electric field. Electric field. Okay, this is the definition of electric potential. Okay, now what we have to do, this is a very important derivation as well. You have to consider a capital source charge. Okay, then you have to consider a charge which is kept at a test charge which is at infinity. Okay, coming towards this charge, but it has not yet reached at this point. So this is a point where we are trying to make the measure the electric field. Okay, and the charge which started at infinity not yet reached the point, but it has reached some point in between the infinity and this point, say a capital X. It started at infinity very long time ago and it is still walking towards the point P. Okay, now how to do that? First of all, this distance is known, this is r. This is, we are assuming that charge started at infinity and reached at a distance x from the source charge. The charge value of the charge is small q. Okay, so what is the force due to this charge? The force due to this charge is basically Coulomb force, k q by r square. In this case not r square, it will be x square because the distance is x. So this is the Coulomb force. Now to bring it from this point to P, you have to apply some external force. The external force must be opposite to that of the force acting on this due to the field. So the external force must be kqp by x square. This much force I have to apply to bring it. This force is applied by the electric field. So this force must be applied by us to bring that charge here. Okay, so this is the external force that you have to apply. Now what is the work done? So suppose now this charge moved by a very small distance dx. Okay, again we will try to form one integral. So the work done is basically given by first let us write the formula. So formula is f external into dx, external into dx. Okay, f external into dx is the work done. Right, now let us put the values of f external, that is minus k q by x square dx. Okay, now we have to find the total work done. So the total work done by external force to bring it from infinity is basically k q p is constant. Okay, so it will be an integration, right, integration dx by x square, okay, infinity to the point r. Okay, starting point was infinity and we are bringing it to the point r, so this will be our integration. Okay, so integration is very simple. So w equals to, I know many of you were afraid of this kind of derivations when you started second PU, but once you have done the integration, this is a very simple integration, dx by x square, which is basically integration minus 1 by x. Okay, so it will be infinity to r. Now this minus sign is common, you can take it outside, so this minus and this minus will be positive now, so it will be k q 1 by r upper limit. Now this minus is gone, right, there is no minus sign. So first we will put the upper sign, upper limit minus lower limit. Now 1 by infinity is 0, so that will be gone, so you will get k q by r. This is the work done. Now definition of potential is unit charge, unit positive charge. Okay, so here as you can see that there is no, this is not an unit charge, that small q is not a unit charge. How can we make this a unit charge? Either by putting that as 1 or more sophisticatedly what we can do is that v equals to work done per unit charge, so w by q, that is k q by r. Now you have to put the value of k, that is you have to put some shirt on. You have arrived to eat some delicious food in a marriage ceremony, so you have to put the dress, proper attire, proper dress. You cannot go there in casual dress, so you have to put the dress now. Okay, so it is 1 by 4 pi epsilon naught. Your banquet is ready, you can eat this now, right? Derive the expression for refractive index of the material of the prism in terms of angle of minimum deviation and angle of the prism. This is one of the most expected question from this chapter, so you cannot skip this as well. So let's see the answer. First of all, you have to draw this diagram of the prism and this minimum deviation graph. Both of the diagrams are compulsory, and then you have to do this mathematics. From geometry we get delta I equals to, this is the angle of deviation, angle of not minimum deviation, this is normal deviation. Angle of deviation is equals to I plus E minus A. From there we can also say that the angle of prism is basically R1 plus R2. R1 plus R2, the everything has to be mentioned in the diagram as just shown in the figure here. Okay, now by observing I versus delta graph, we can see that the angle of minimum deviation occurs. So angle of minimum deviation is not there. Angle of minimum deviation occurs when angle of incidence I is equal to emergent angle E, that is I equals to E, and if I equals to E, then R1 must be equals to R2, right, and that should be equals to say R. Okay, now from there we can say that, so delta M equals to 2I. Now if you put I1 equals to E, so that is I plus I, so 2I minus A, that is I equals to A plus delta M by 2, and then you get A equals to 2R, that is R1 plus R2, both of them are equals to R, so R plus R, that is 2R. So from there you can get the refractive index of the prism, mu or n equals to sin I by sin R. So sin R is from there will be one more line here, that is R equals to A by 2. Right, so now just put the values over here, so and you get the answer. N21 equals to sin A plus delta M by 2 into divided by sin A by 2. Okay, Arrive at the balanced condition of Wheatstone bridge using Kirchhoff's rules. This is also very expected question. This question was expected last year, but it did not came. But this year might be this is the year where you get all the expected question. So first of all, you have to draw the diagram. Remember the diagram very well. The diagram shape of the diagram is similar to Kaju Katli that you like the most, right? So this is P, this is Q, this is R, this is S. Okay. Say current through this, say I1, current through the galvanometer, say IG, current through this will be I1 minus IG, current through this, say I2, current through this will be I2 plus IG. Okay, this diagram is very simple. I1 current is going here, it is branching, one current IG is passing through the galvanometer, so remaining current I1 minus IG will pass through the resistance R. Similarly, I2 current is coming here, IG is also coming over here, both are meeting, so I2 plus IG. Okay, now this is the basic diagram. Now we will apply Kirchhoff's laws in two loops. Okay, one loop is A, B, D, A, B, D, A, and another loop will be B, D, C, B. These two loops we will apply just in the direction that I have mentioned, A, B, D, A. So we will start from A, we will go to B, then from B to D, then D to A. Now if you don't know Kirchhoff's laws at all, only thing that I have to remember is whatever is the current times the resistance, that you have to add according to the direction. If you don't know, just remember this. Okay, so for example, I am going from A to B. Okay, A to B I am going, what is the resistance? Resistance value is P. What is the current? Current is I1. So multiply them, P, I1, just like that. Now you have to continue this process. Now we have arrived at B. Now we are going from B to D. Current in the direction of current or not? Yes, in the direction of current. Now what is the resistance here? Resistance of the galvanometer generally represented by G itself. So don't worry. So resistance is G, current is IG. So what we will write? GIG. Now because we have gone in the direction of current, the sign is plus. Now we have arrived at D. Now we have to close the loop. For closing the loop, we have to reach to the point from where we have started. So you have to write from KVL along loop A, B, D, A. Okay. Now you have to reach to the point A. Now here, while reaching to the point A, you are seeing that, hey, the current is in the opposite direction. So what to do? So in this case, there will be a negative sign first, and then the same thing, Q into I2. Q is the resistance, current is I2, and if there is a battery connected in this, then you have to do some difficult mathematics. But since there is no battery connected, you can simply write 0. This is as simple as that. Okay, now this is one. You have to practice this 2-3 times. If you have not, you don't know KVL, you have not studied this at all. Now second is, we will start from B, D, C, B. So B, D, again applying KVL in loop B, D, C, B. Okay, so where we are going from B to D, again IG into G or G into IG. This is the first resistance, first current. Now we are going from here to here. Okay, resistance is S, current is I2 into G. Again same direction as current, so it will be plus. So it will be S, I2 plus G, plus IG, sorry. Now next is we are going from C to B. Okay, now C to B, if you see that we are going in the opposite direction of the current. So this current is in this direction, but we are going in this direction. So there will be a negative sign, and that will be R into I1 minus Ig equals to 0. Okay, so this is the two equations that you have to write. Next part is easy. First two equations writing is difficult. Other than that, everything else is simple. What is that? That for balanced condition of Wheatstone bridge, okay, Ig equals to 0. Okay, so when the Wheatstone bridge is balanced, then this current Ig becomes 0. Now what we have to do? We have to put Ig equals to 0 in both the equations. From 1, therefore from 1 you get Ig 0. So Pi1 minus Qi2 equals to 0, right? And then again from 2 put Ig 0. So this is 0, this is 0, so only this is left, Si2 minus, again this becomes 0, so minus Ir1 or Ri1 equals to 0. Now you have to simplify this. So Pi1 equals to Qi2 or P by Q equals to I2 by I1. Similarly, you can write from here that Si2 equals to Ri1 or equals to obviously equals to no 0. So R by S equals to I2 by I1. Now if you see, this side is also I2 by I1, this side is also I2 by I1. So comparing these two, we can write that P by Q equals to R by S. This is the condition for balanced in Wheatstone bridge. Okay, so this is a simple straightforward derivation. Only thing that you need to practice these two equations. Okay, now as I said, this was expected last year, but it did not come, so maybe you are lucky guys that this will come in your year. Okay, derive an expression for magnetic field at a point on the axis of a circular current loop. This is also very important derivation. Let me do it quickly. We have a circular coil. We are trying to find the magnetic field at the axis of the coil. Okay, at a distance say x from the center of the coil. The radius of the coil is r. Let us consider a small element dl like this here. Okay, and we want to find the magnetic field here. So this distance say r. Now Pythagoras theorem gives us r equals to square root of x square plus r square, because this angle is 90 degree obviously. Now this angle say phi, the angle between the element and the length is 90 degrees, so theta is 90 degrees. Okay, now what we have to do, we have to remember this. So this is the magnetic field dBx due to this small element, and this angle will be phi, and you have to basically find the x component. Okay, this is dB, the small element, this will be dBx. Y components will be cancelled. How it will be cancelled? You don't need to know right now because you have not studied, so you don't need to write that as well. So only thing you have to write that y components will be cancelled, only x component we have to find. So first, what is dB? From Biot-Savart's law, dB is equal to mu naught by 4 pi I dl sin theta by r square. Okay, This is the first sign. Now theta is 90, so sine 90 will be 0, so it will be mu naught by 4 pi I dl by r square. Okay, sine theta is 1, sine 90 equals to 1. Okay, now what is the x component? dbx. So dbx will be equals to db cos phi. Cos phi, now put the value of db, mu naught by 4 pi I dl by r square into cos phi. Cos phi is, this is phi, so cos phi is adjacent side times hypotenuse. So adjacent side is r here, hypotenuse is small r here. So this is the thing. Now we have to simplify it. So mu naught by 4 pi I into r divided by r cube into dl. Now this is due to a small element dl. Small element dl. Now you have to find the due to the entire coil or entire loop. So entire magnetic field will be, say, bx will be equals to integral of dbx. Okay, now if you see that in entire thing, everything is constant except this dl. Okay, so let me write that mu naught by 4 pi, okay, IR by r cube integration of dl. Now what is integration of dl? If you take this small dl, if you add all the small dl's, basically that will be the perimeter of the circle. So let me write that. So mu naught by 4 pi IR by r cube, perimeter of the circle is 2 pi capital R, right? Radius is capital R, so it will be 2 pi capital R. Okay, so this cancels, 2 left here. So the final value you get mu naught by 2 IR square by r cube. Now r cube, r was this. Okay, so r was this means r cube will be, or you can say r is basically x square plus r square to the power half. Square root means to the power half. So if you do the cube of that, so basically it will be 3 by 2. So x square plus r square to the power 3 by 2. So this is the final expression. Okay, if you can solve that, you get 5 marks. Okay, diagram is important, diagram is compulsory, and the derivation you have to practice 2-3 times again. Now this is a common question. What is a rectifier? Explain the working of a full wave rectifier using a neat circuit diagram. Draw the input output waveform. So full wave and half wave rectifier, one of the question will definitely come this here as usual. So this is a very common short question. Okay, so a rectifier is an electronic device that converts alternating current AC into direct current. Now you have to for full wave rectifier there will be 2 diodes. The diagram you have to practice. This is a must have. This is going to come in your exam. Practice it properly. Don't use the space. Don't draw a small diagram that the teacher need to use a microscope to see that diagram. So explain, draw the diagram as big enough, okay, and then explain it step by step. Okay, in the positive half cycle of the AC input voltage, the upper half of the transformer secondary winding becomes positive. So what happens? Diode D1 becomes forward biased and conducts, allowing the current to flow through the load resistor RL. Diode D2 is reverse biased and does not conduct. So in the first half of the input cycle, diode D1 conducts because this is forward biased. So current passes through RL as shown in the direction. That's it. Now next is a negative half cycle of the input half cycle. So this is called positive half cycle. This is called negative half cycle. Okay, so something happens in this cycle, something happens in the other cycle. Okay, so in the first half cycle diode D1 conducts, in the negative half cycle same thing, diode D2 conducts. So that is the same thing you have to mention. And then you have to mention one more important thing is that the current flows through the load resistor RL in the same direction as during the positive half cycle. That is very important point. Now What is the half wave rectifier? Explain the working of a half wave rectifier using neat circuit diagram. Also draw the input output waveforms corresponding to it. So let's see, half wave rectifier is an electronic circuit that converts alternating current AC into direct current DC by allowing the flow of current only during one half cycle of the AC input signal. The other half cycle is blocked, so only half of the AC wavefront is used. Okay. Now positive half cycle to AC, during the positive half cycle of the AC input, so you have to mention both half cycles no matter what is the diagram you are using. So whatever is the given to you, half wave rectifier or full wave rectifier, does not matter, the diagrams will be different. So half wave rectifier only one diode will be used, the output form will be different, input wavefront will be same for half wave as well as full wave. So you better draw this dotted line so that you can match them. Don't mess it up, use scale, okay, use proper pencil or pen to draw the diagram. Pen is fine, but use scale to draw the diagram, okay. Don't use normal hands. Obviously if you are at the brink of failure, okay, write whatever answers are common, at least best possible way, so that you can score well. Okay, during the positive half cycle of the AC input, the anode of the diode is positive with respect to the cathode. The diode becomes forward biased and conducts current. Current flows through the load resistor RL in one direction and the voltage across the load is positive. Negative half cycle, during the negative half cycle of the AC input, the anode of the diode becomes negative with respect to the cathode, so the diode reverse biased and does not conduct, so no current flows through the load resistor RL and the output voltage 0 during this half cycle. Okay. So this is the end of this passing package. Obviously if you don't want to waste any time and want to download the PDF, then definitely you have to subscribe to our channel. I'll be back with a new video later. Right now your Canada and mathematics subjects are priority, but till then, bye. I will see you later before your physics exam.